Hello everyone, I hope you are doing great. In this video, I'm going to show you how you can compute Jalal Bentler Monte Carlo probability value for the Satora-Bentler scaled chi-square in EQS 6.4. So this feature is a new feature in EQS 6.4, and if you would like to have some technical information about this procedure, you can consult supplements to EQS 6.4 for Windows User's Guide, and the information are on page 41. So this procedure is based on the work of Jalal and Bentler, and through this procedure, what happens is that EQS generates a Monte Carlo simulation based p-value for the Satora-Bentler scaled chi-square when your data are complete. Also, if your data are not complete and you have missing values, then this p-value will be computed for the Yuan Bentler scaled test statistic in EQS. And the beauty of this feature is that it can also be applied to the PLSe2 methodology. So normally we are using maximum likelihood, but if you also use PLSe2 methodology to estimate your model, still this procedure can be applied. So by default, EQS takes 200 samples and computes the p-value. If the p-value resulting from the simulation based on these 200 samples exceeds 0.2, then it will be the final p-value. Otherwise, EQS increases the sample size to 500 and does the estimation 500 times and then compute the p-value for this simulation. So certainly it will take a longer time comparing with just a single standard analysis. And in order to get the Monte Carlo probability p-value, what you need to do is that you just need to specify method is equal to ML and robust. The interesting part, as I mentioned, is that you can also consider PLSe2 methodology here. So you can replace ML with PLSe2. And under the print section, you just need to add Monte Carlo is equal to yes, or simply MO is equal to yes. Alternatively, you can select the Monte Carlo option under the print dialog box. So let me just go to EQS and specify a simple mediation model and then show you how you can get these results. Let me open my data file here. So this is the data file that we normally use. Here we have a few indicators for different latent variables. So we have interpersonal conflict with 4 items. We have positive affect with 5 items, and also we have job performance with 5 items. So I would like to see if positive affect can mediate the relationship between interpersonal conflict and job performance. So this time, rather than using this dialog box, new model helper, I'm going to build the model based on the interactive method. So I'm going to select title specifications, and then here you can see that the estimator is maximum likelihood. I also select robust methods, and then I click OK. Now here you can see that the method is maximum likelihood and robust. We also have 1000 cases and 38 variables in our data set. Now let me define the equations for my mediation model. So I have 2 factors, and I don't want to use all the variables in this data set. So I deselect this option. Then I click OK. And now here I have to select the indicators of my 3 factors. So interpersonal conflict 1, 2, interpersonal conflict 4 are the 4 indicators of interpersonal conflict. Then we have PA1 to PA5 as the indicators for positive affect, and performance 1 to performance 5 as the indicators of job performance. Then I click OK, yes, and now here I would like to specify which factor loadings are fixed to 1 and which factor loadings are freely estimated. So focusing on interpersonal conflict with 4 items, I set the factor loading of the first indicator to 1 because it will be the scaling item, and the rest are asterisk, meaning that they will be freely estimated. So for positive effect, again, the first item will be the scaling item, which is fixed to 1. The factor loading for the first item is fixed to 1, and then for the rest, we use asterisk, so they will be estimated, and we have the same situation for performance. Okay, and now if I just scroll down, you can see that I can define the relationship between the latent variables. So interpersonal conflict predicts positive effects. That's why I just insert one asterisk here. Also, interpersonal conflict and positive affect, both of them predict job performance. So I insert asterisks here and here. Now I have defined the relationship between my three factors as well. So I just click on OK. And here you can see the factor of the variance of my independent factor, which is interpersonal conflict. It is asterisk. It means that it will be estimated. All the residual variances are estimated as well, as you can see, plus the D2 and D3, which are in fact the disturbance variances of my other factors, including positive effect and job performance. So I click OK, and now you can see that the model has been specified based on the interactive method. So you can see all the equations, variances, and the covariances. Obviously, we don't have any covariances. That's why you don't see any covariances under the covariances section. Now I just go to print and I select Monte Carlo. I also select compact because I would like to see the output of EQS in compact mode. So I just select this. If I click OK, you can see that the model file is complete and I can simply run my EQS file. So let me just save this as mediation model, and then I click on save. Now you can see the simulations being run. Okay, so let me just scroll down. This is the results report. You can see that our data are multivariate, not normal, because the normalized estimate of multivariate kurtosis is 52.94. So it's greater than 3. And that's why we are going to ignore the theta statistics and the chi-square statistics here, and we just focus on the robust statistics. Now, if you look at here, you can see the Satora Bentler scale chi-square, which is 417.56, and the degrees of freedom is 74. You can also see the probability value for this chi-square statistic. And if I just scroll down, you can see this section here. Jalal Bentler Monte Carlo model probability is 0.000, which is very similar to the p-value we observed based on the Satora Bentler methodology. In this case, they are similar. Sometimes they are different. And by the way, this is the more accurate value that we have. And normally we can report this. So you can see that we can get the p-value here based on Satora Bentler methodology. At the same time, we can get the p-value for the Satora Bentler methodology based on Jalal Bentler procedure. So this is how you can get this probability value. Now let me just share with you one of my recent publications through which we use this procedure. So the title of the article is Lecturers' Personality Traits and Affective States Amidst the COVID-19 Pandemic, Estimating a Theory-Driven Longitudinal Model Using the Novel PLSe2 Methodology. So in fact, this is the first article published through which a longitudinal model has been estimated using a PLS-based approach. And let me just go to the results. Here, you can see the hypothesis testing results. And if you look at here, you can see that we have reported the Satora-Bentler scale chi-square with 59 degrees of freedom, which is 109.26, and the p-value is smaller than 0.000. But if you look at here, you can see that we have computed the Jalal Bentler Monte Carlo model probability based on 500 simulated samples, which also converged with no condition code, and the p-value is 0.002. So we have reported both p-values, but certainly this one is a more accurate p-value for the Satora-Bentler scale chi-square. And as you can see, we have computed these based on PLSe2 methodology. So not only this Satora and Bentler approach is applicable to maximum likelihood, but you can also consider that when you are estimating your models based on PLSe2 methodology. So it was all I wanted to share with you about Jalal Bentler Monte Carlo probability value for the Satora Bentler scaled chi-square. I hope you enjoyed this video. Thank you very much for watching.